So today we're going to focus on scanning and scanning technology. At the core of scanning devices, they do one thing. They capture reality and bring the real world into digital computing. It's a higher level of accuracy and completeness than with any previous method of manually measuring. So in order to really help you decide what scanner is right for your business and your particular needs, we need to cover some of the basic fundamental understanding of scanning technology. Scanning really falls into two primary categories: long range, known as terrestrial scanning, and close range, known as part scanning or metrology. Part scanning evolved from the traditional CMMs and digitizing arms of the past, and it's now achieving really amazing levels of accuracy. Terrestrial scanning originated with more traditional surveying techniques, such as total stations. It's now grown into a distinct piece of equipment and is capable of scanning large areas very, very quickly. In kind of general terms, higher accuracy equals shorter range for the scanning devices. They can range anywhere from permanently installed units that can get down to 4/10,000ths of an inch, up to and really have limited scanning range, up to the very high end that are really only accurate to about 1/2 an inch, but can go over 2,000 feet in range. Next thing up is to talk about the different types of scanners that are on the market today. In terrestrial scanning, there's about a dozen or so major scanners on the market. They have a number of common traits. All the scanners that are out today use a process referred to as full dome scanning. What that means is that while pulsing a laser, they rotate a full 360 degrees in the horizontal axis. At the same time, they're rotating in the vertical axis. They rotate 360 in the vertical, but because of the base of the machine, they typically can only pick up about 270 to 300 degrees in the vertical axis. Using the rotation and some pretty precise sensors and basic math, they're able to generate precise distance from the scan head at an angle. The best units on the market today can scan over 1 million measurements per second at their fastest speeds. There's slight differences in how they work, though. Some are what are called time of flight, while some are phase shift. Both these involve emitting a laser pulse from the scan unit and measuring either the time or the phase shift of the waveforms that are coming back to calculate a distance. In the past, these were really distinct. Phase shift would produce very fast data, but it was a little messy. It wasn't quite as crisp as the time of flight. Time of flight was much slower but produced much cleaner data. Nowadays, with the newest units on the market, whether that's the newest Pharaohs, like the Pharaoh 330 or the Leica P20, they've really equalized. They both produce extremely clean data at very high ranges. Another interesting thing about the terrestrial scanners is they can be equipped with cameras that allow you to capture true world color of objects and map those onto the scan points. When you get into part scanners, the market's much more diverse. There's dozens of different manufacturers, all with different technologies. What this means is that it's much more difficult to select the right part scanning technology for what you need to do. In today's discussion, though, we're going to focus on what's really the most general purpose, widely used of the technology, and that's the scanning arms. That's shown in the lower right image. These arms allow you to scan parts of pretty good size, and they combine a probe along with the laser scanner to produce extremely accurate measurements of parts and products. Aside from kind of the two we're really going to focus on today, there's several other types that are worth knowing about. Start with the CT scanners. These are same type of equipment that you'd see in a hospital. They're simply much greater power. They can scan at very, very high resolution and very accurate, up through about an inch of solid steel. These are definitely in the realm of specialized equipment. They are not mobile, and typically you would send parts out to people that own these units. Another type that's gaining some traction lately are aerial drones. These are remote controlled quadcopters that have cameras mounted to the bottom of them. They take thousands of pictures. Those pictures are processed through specialized software that generates a point cloud out the other end. Another type is ground penetrating radar. Today this is really the only way to see through solid ground that's safe for use around people. Another one is laser trackers. These are highly accurate and they're long range, but they don't capture that many points. They're typically used for very complicated installations where precision is the utmost importance. They can also be paired with more traditional part scanners or even terrestrial scanners to create a tighter registration of multiple scans. There's also another class which are the mobile and mobile aerial scanners. These are relatively large units. They tend to be mounted to either cars or airplanes and are capable of capturing huge volumes of data very quickly. You'll see them mostly in civil engineering and mapping disciplines. The last kind that I'm just going to touch on really quick is combining cameras with range sensors. This is kind of I'd say the low end of scanning. You can get into it for a few $100s. It will capture data. These use things like the Microsoft Kinect or another device from Asus, and they allow you to capture all right data. It's not very accurate. It takes a fair amount of work to make it usable, but it's an interesting new addition to the field. So let's talk a little bit more about part scanning and kind of how it's used in its different applications. So it typically falls into two main categories and then different offshoots of those. That's quality inspection and reverse engineering. When you get into quality inspection, you're using the accuracy of the data captured to pick up very small changes in the part from design. This typically will involve overlaying the scanned data over a known part that was designed in CAD. Automated tools are then used to create difference mapping that you can see in a lot of these images. With the accuracy, its field really lies in injection molding and sheet metal design and stamping. In reverse engineering, that's any time you have a part, you have a real physical part, and you need to get engineering data out of it in order to reproduce it. And that's where these machines really shine. They capture data at an incredible resolution and accuracy. So that image in the upper right of that part's actually only about 1.5 inches across, and it's able to capture that kind of data. Kind of a quick overview of how you would get parts scanned or scan them yourself. You'd start by selecting the scanner, and like we discussed earlier, there's a lot of different models on the market that have different pros and cons. But once you've kind of decided on a scanner for your need, the next decision would be, do you want to do it yourself on site, or can you ship the part? It's typically a lot more cost effective, especially if you're contracting the work to ship the part out, but obviously there's some parts that can't be shipped. Once the part is scanned, you're going to almost always create a model of some kind. This can be a pretty basic NURB surface, which is just triangles, or a much more complex part for reverse engineering that's properly constrained. Once that's done, you're going to basically overlay the model and verify it for quality purposes, or you're going to reverse engineer it and turn it into that real dimensional data you need to reproduce the part. I'll jump back to terrestrial scanning for a minute and how it's used. It's typically used in a facility, and we eliminate the other use, which is civil engineering. We're going to focus on facilities, though. It's used really through all different steps of the design process for a facility or a building. The two primary places where you'd want to get into it is either in the very earliest stages of the project or in the as-built phase. These are really the two entry points. As you become more sophisticated in integrating it into your day-to-day workflow, you'll often find it can make sense to scan multiple times during the project for specific reasons. The process for terrestrial scanning is the same on every project. You're going to start by having a good plan. What you want to scan, what you want to capture, what things are important to you, what are less important to you. Once that plan's designed and laid out, you're going to actually go to the field and do the scanning. You're going to set the scan up anywhere from a few times to a few thousand times, depending on the square footage. You're then going to bring those scans together in an application that lets you stitch all the scans into one unified cloud. You're then going to link it into your design or engineering software. And you can either create a model of all the scan data or selectively model from the data key components that are needed for the ongoing design or support. Software is a very critical part of this equation. Oftentimes people think that it's just the scanner and the hardware. The software is very important, and it's going to be governed by what exactly you want to get out of the scan data. And it falls into three categories. It's the data collection software. In this case, this is mostly for part scanning. Most of your terrestrial scanners now operate without any special software. Part scanning requires some form of software to actually control the scanner while you're scanning. The two biggest players in that are Geomagic and Polyworks. These are also modeling applications and post-processing applications, but they allow you to control most of the part scanners on the market. Also, it's worth noting all the scanner manufacturers sell their own software or give it away with the scanner. In general, you're going to find that their software is pretty limited, and you're pretty quickly going to want to move into a Geomagic or a Polyworks. Once you've captured the data, there's going to be a post-processing step. In the world of terrestrial scanning, that's going to be stitching your individual scans together and doing cleanup, removing noise such as people walking through the scan, segmenting the data into workable data sets, things like that. In the case of part scanning, it's going to be much more focused on generating some basic model geometry, cross-sections, all the kind of things you'll need to do either your comparisys analysis for inspection or you're going to need for generating your reverse engineered CAD models. The third piece is what most people already have, which is the modeling piece. Nowadays, point cloud data can be brought into just about any traditional engineering application: Inventor, AutoCAD, NX, CATIA, ProE, SolidWorks. All of them have different modules that support the data coming in. For the few that don't, there are still ways to get usable data into those applications and get value out of it. The next kind of step is how you get started in scanning. And this is very important and involves working with people to get them on board. The basic 7-step plan that really applies to not just scanning but any kind of new technology or workflow you're going to integrate into your business. It starts with getting power users and executives to really sponsor the program and understand the value of why you want to do it. Once you get that, you need to establish clear goals and priorities of the program. Understand that people are inherently resistant to change, and you're inevitably going to be fighting an uphill battle. You need to identify the right people in your organization who are going to be willing to try out something new and adapt to it and look for new ways of using it. Step 5 is really making sure that the people you've identified are trained and they're trained well. This stuff can be very easy to use until things go wrong. And they inevitably do, and you need to be up to speed on how you deal with that, or have someone who can call who can walk you through it. Number 6 is measuring results. Very important that you be able to have measurable results that you can take back to your leadership to show that the program is working. Once you have those results, you need to market them internally to your partners to get them to understand why you want to do this and keep the project growing. The next thing up is purchasing hardware. You're going to, similar process, you're going to start by identifying the requirements, come up with a realistic estimate of the cost. And this includes software, hardware, and the training that's going to be involved in the program. Another tip is really consider the total cost of ownership over the first cost. All these pieces of hardware involve ongoing maintenance contracts, and you'll see a pretty diverse price range in the costs between manufacturers for those maintenance agreements. The equipment typically has to be certified at least once a year. That involves shipping it back, and that can run anywhere from a few thousand to over $10,000 per year. The other tip is really shop around. There's a lot of variance, especially in the part scanning world, in the cost of the different hardware that's on the market, and make sure you're really buying what you need. When we get into selecting software, the first step is really see what you already have in-house and how it can work with the scanning technology. Kind of help minimize the initial investment in software. All the modeling applications that are out there now do support point clouds in one way or another to differing levels. Some of them you may want to supplement with different plugins. Some will simply work right out of the box. For example, all modern Autodesk applications support point clouds natively, and they do it very well. Important to know that software can cost as much as the hardware, especially when you need multiple copies. So where you may have one person out scanning and collecting the data, you may have 10 people working with the data. You're going to need 10 copies of that software for them. Don't buy software without training. This stuff can get pretty complicated, especially on the software end. Make sure that anything you buy is coming with a day or two of training included. Also, an important point that software is really the fastest changing part of the scanning technology. The equipment has stabilized, it's getting progressively better, but it's more of an evolution that's happening within the hardware. New software is coming to the market every year, and it's greatly changing how you work with the data. Everything from automated registration of the data sets to automated extraction of common geometry such as pipes or surfaces. So we're going to now talk a little bit about subcontracting out the work. That's a good place to start before you make an investment in all the hardware and software. And there's some things to really keep in mind when you're contracting it out to make sure that the people you're partnering with are really the right people for you. There's a lot of different companies now offering this as a service, and there's a wide range of skill sets and specific industries that they're best suited to help with. So these are some questions that you should definitely be asking of the supplier when you're doing scanning. Do they have experience in similar projects? So if you have someone in terrestrial scanning, it's very common for a lot of civil engineering firms to be offering as a service. Well, if you're dealing in high-end process equipment, they might not be the best pick for you. If they've only scanned fields, runways, and roadways, they're going to struggle to scan inside and keep quality control. The next question is, do they have quality control procedures in place? And you should definitely ask to see a copy of them. Especially when you get into multiple scan setups, having a solid quality control plan is what's going to make sure that the data coming out is of the top quality. As we discussed, these things have to be calibrated. Do they have those certificates, and have they been updated within the last year? Some companies out there are trying to save money and are not getting their equipment certified. Another question, especially in the part scanning world, do they own the correct hardware? Are they trying to use a device that's simply not suited for what you need to get out of the data? Maybe they own an optical scanner, one of the white lights or structured light scanners, and what you're most concerned with are exact hole locations in sheet metal. That's where you really need an arm with a probe on it to capture that exact edge. Another one, do they have a really solid backup procedure? These things generate, especially in the world of terrestrial, very, very large data sets. A big project can easily climb to over a terabyte in size. If they don't have solid backup procedures for that data in place, you run the risk of having them come out and scan for several weeks only to lose your data back in the office because of a hard drive failure. And lastly, do they know more about your industry than just scanning? Have they been involved in your specific industry in other ways other than just scanning? And this ties in a little to the first question too. I wouldn't eliminate someone simply because they don't do more than just scanning, but it definitely helps if they understand the bigger picture of your process. So we'll jump into some questions about modeling. These are really distinct parts of the scanning process. You're typically going to have your people that collect the data and then your people who process it into models or do the quality analysis on it. So a lot of the questions should be the same, but they should be asked in regards to modeling. Have they modeled similar things before? Maybe you have a very complex organic shape that you need scanned and modeled to a high degree of accuracy. That's very different than a machined part. Again, do they have quality control procedures? How are they checking the data that they've generated in CAD back to the point cloud to know they've met the tolerances that are needed? Do they own the correct software? So if you need a parametric data-driven model, that can't be created in a software product you're not using. So if you're on Pro-E Wildfire, they also must be on Pro-E Wildfire. Again, do they have backup procedures in place? You don't want to get 2 months into a project and get a phone call that they've lost your data. Can they provide samples? You should always request, especially in part modeling, that they provide you with sample models that show that they can create the kind of geometry you're looking for. And lastly, do they have modelers that are experienced in the application? A lot of places out there will buy an application and assume that their modelers can just get up to speed. Maybe they have people that know CATIA really well and they feel they can just pick up a seat of NX and knock your model out for you. That's not going to work out well. You need people that have done this work before and that understand exactly what's involved. And lastly, questions that you should really expect from anyone who you're subcontracting modeling out to. These are the kind of questions they should be asking you, and if they're not, you may have a problem. First off, they should always ask for any kind of CAD or design standards you have in-house. This is really important. If they're not asking this, they probably haven't done a lot of this work before. If they had, they would have been burnt by this before. Anyone who's doing this work really needs a copy of any kind of CAD and design standards you have. This is going to be the baseline for them doing work for you to make sure that it's usable within your current systems. They're definitely going to ask what applications you use. Are you using CATIA? Are you using Factory Design Suite? Are you using Factory CAD? This is very important so that they can try to align as best they can. It could be that your needs are for a basic model and they don't necessarily need to be in the same software, but they should at least make an attempt to be in the same software. Another question is what type of output model you need. Do you need a basic solid model, a surface model, a mesh, parametric, constrained? There's a lot of different types of modeling out there, and they're very specific and can do specific things. So if you're doing a quality analysis, a surface or mesh model will work just fine. If you're doing true reverse engineering, you need a parametric, properly constrained model. Or if you're into maybe BIM or factory design, you might need a data-driven model in which the objects contain more than their geometry. They contain specific properties about the object. They should really ask some specific questions about your business and the particular project that they're getting involved in. You wouldn't want someone coming out who thinks they're just out there to scan and hand something over to you. They should have some questions about, why are you scanning? What are your goals with the project? And how is it going to really align with your business? Definitely level of detail and design accuracy are very important. Without clarifying this, there's different standards out there. What you get back might not meet your expectations. This could be a relatively basic discussion, or it could be a pretty in-depth one of exactly what you need. Lastly, the data richness. This is beyond the geometry, what's going to be included in the model. So if it's a part model, are they going to include physical properties about the elements used in constructing the part? Are they going to label it as aluminum in the proper grade? Or if it's a factory or a building, are they going to include energy analysis type information, warranty information into the individual parts that are included?